So after the review, those are Math 9 concepts. After the review, how do we actually multiply polynomials that involve multiple terms? We saw the concept of FOIL, expanding polynomials by using FOIL, or technically expanding a product of two binomials together. But make sure you know how to use algebra tiles. When I'm to multiply x plus 3 with x minus 1, that means I'm starting with some rectangles or algebra tiles. Starting with x plus 3 on one side. And on the other side, I have x minus 1. Well, but how do I indicate the plus? How do I identify the minus from the plus? In your book, they use clear tiles to represent negative, and they use colorful tiles to represent positive. So let me follow the same idea. Positive x plus 3. So we are going to see algebra tiles that come with x squared, 1x, 1x, 1x. These are positive tiles, with each of them giving us 1x for its area. How do I get 1x? Knowing how we start with the square tiles at the beginning with 1x on this side, and the length here is 1. The area for each of these rectangular tiles would then be 1 times x. These are all positive tiles. So I'm going to shade it. But then there is a minus 1 on the other side. The minus 1 on the other side, yes, it will still give us a tile, but now it is a negative tile. The area for this negative tile would involve length times width. Yeah, we have negative length, doesn't quite make sense here. But this is how we use algebra tiles. And then in order to fill in the space with some little square, we have 1, 2, and 3 of them. We need 3 little square to fill in the space and create a rectangle. The area of these rectangles will be length times width, negative 1. Once again, length times width, and then again, length times width. So all together, we have x squared from this big square tile. And then with 3x minus x, we have 2x. And finally, minus 3. This is how I would expand the product of two binomials using algebra tiles. But as you saw in the previous lesson, the method of FOIL can easily do the work without all these joins. So we can use the distributive property to expand product of binomials. Whether it is a monomial multiply a binomial, you distribute your x into the second bracket once and for the second time, or you can use the concept of FOIL to multiply your binomial. first, outside, inside, and then last. The expansion in example 3 here is what we call FOIL. Once you have enough practices on FOIL, we will then reverse the process and try to do something called factoring trinomial. But today we will focus on expanding the polynomial, multiplying the terms one at a time, and come up with our result. So for the next one, if you were to expand it, I'm going to use the concept of FOIL. First, and then outside, you keep multiplying the terms, and then inside, negative 3 times positive 2x give us minus 6x, and finally last, the last term of the two brackets, negative 3 times positive 5 minus 15. Don't stop here. After you expand your product, very likely there will be some like terms to simplify. Typically, the middle two terms. When you want to expand your polynomial by FOIL, very often the outside and the inside will give us like terms, and you can combine the like terms together, giving us a trinomial at the end. Sometimes the questions don't give us two brackets. They want you to come up with two brackets. And they can do so by using square. For example, for B, you see a square for your bracket. That basically means the same thing as multiplying 4a minus 3b by another 4a minus 3b. And once I've expanded, once I've turned the square into a product of two binomials, I can now expand it by FOIL. 4a times 4a. 4 times 4, a times a, altogether 16a squared. This is first. Then the outside. 4 and 3 give us 12. Don't forget your minus. And then a times b. That's the outside. Then the inside. Then the last of the two brackets. And once again, we see like terms. Group the like terms together before you call it your final answer.